All right, so it's been a while, but we're going to start with the videos again. We're going to be looking first at transformations of the exponential function. So from the exponential function that we learned about yesterday, we are now going to transform it just like we did in our second unit, transformations of functions. We're going to use mapping notation just like we did before, but we have to apply it to the exponential function. Now, the exponential function, so in this first example, it would be 3 to the power of x. The points that we map are going to be a little bit different depending on what the base is. So I'm going to explain to you how we can find those points. But first, let's just talk about the mapping notation. If we have 2 times 3 to the power of x minus 4. Now, I already highlighted here 3 to the power of x. That's our base function, or our parent function like we used to call it. So the question is, what does the 2 do to the function? What does the minus 4 do to the function? Now, 2 is multiplying the function. If you remember, this was the same thing as our a value. Our a value is 2. Now, we're subtracting 4 on the outside of the function. Okay, this is our vertical shift up or down. That is our c value. So if I were to write my mapping notation, any point x, y becomes... Now, for this one, nothing is happening to x. Nothing is happening horizontally at all. But what is happening to the y values? The y values will first be multiplied by 2 and then subtracted by 4. So this will do a vertical stretch by a factor of 2 and then shift down 4. All right, so what points do we use if we're graphing the function 3 to the power of x? Now, one thing we can always do is, any of these exponential functions, if x is equal to 0, the y value will be 1. That one will always be true. Now, it does change if x is equal to 1 or x is equal to negative 1. These are points that we're going to draw. Now, just think about it. Our base is 3. We're saying x is 1. So 3 to the power of 1 is 3. If x is negative 1, we're saying 3 to the power of negative 1, which is 1 over 3. Now notice how I'm using a fraction here and not any decimals. So those are 2 more points that we can use. Now, I'd like you to go a little bit further. I'd like you to fit as much on the grid as you can. So for example, would we be able to use an x value of 2? Well, what is 3 to the power of 2? It's 9. Okay, so maybe that would fit. And same thing, if x is equal to negative 2, 3 to the power of negative 2 is 1 over 3 squared, which is 1 over 9. So for x values going from negative 2 to positive 2, that's what I'd like you to plot out. So just imagine that you're substituting in those x values as your exponent for whatever the base is. All right, so now we can apply our mapping notation to all of these. So nothing is happening to the x value. So I'm going to keep those x values exactly the same. Now, we did things kind of out of order here. So maybe next time or the next example, we'll do things in numerical order. If the y value is 1 for this first point, we got 2 times 1 minus 4. So 2 minus 4 is negative 2. So the point 0, 1 goes to 0, negative 2. The point 1, 3, so again, 1 stays the same. Now 2 times 3 is 6, minus 4 is 2. Same thing, even if you have a fraction, we still want to do this. So negative 1 is our x value. Now 2 times 1 over 3, if you have to do some rough work off to the side, you can. 2 times 1 over 3 is 2 over 3, minus 4. Now 4 as a fraction with 3 as a denominator would be 12 over 3. So that would be 2 minus 12, that'd be negative 10 over 3. Now, x value of 2, y value of 9, 2 times 9 is 18, minus 4 is 14. So it actually ends up, I'm not going to be able to fit that point on my grid, but I'm glad that I tried it out just in case. And last one, 1 over 9 times 2. Okay, so 2 over 9 subtract 4. Now 4 with a denominator of 9 would be 36 over 9. So it would be negative 34 over 9. All right, so definitely not going to be able to fit, or we can fit that one, but we can just roughly estimate where it's going to be. All right, so now I'm just going to plot the points and draw the curve. So I'm going to pause this video and then draw it, and we'll take a look at it afterwards. All right, so this is what the curve looks like. Now, I drew it that it was increasing, okay, once we pass the point 1, 2. We know that's going to be shooting upwards so that we can somehow reach 214. But you notice how I just stopped down here. Now, the question is, what does the curve look like the rest of the way? Like, does it look like this, for example? Well, what we have to think of, try to remember from yesterday's lesson, we have an asymptote for this function at y equals 0. So if I were to draw a dotted line like this, y equals 0, the curve is not supposed to be crossing that. But obviously it is, in this case at least. So the question is, what is going to happen to that asymptote y equals 0? Now take a look at our mapping notation. What is happening to the y values? They are doubling and then subtracting 4. All right, so what happens when we double 0? 0 minus 4 is, we should have an asymptote at y equals negative 4. So in order to properly draw these exponential functions, we have to know where the asymptote is. It is like so. All right, so now I can draw the rest of my curve that gets closer and closer and closer to that asymptote, but doesn't actually cross it. So that's how we transform the exponential function. So the actual mapping notation should be review, but we'll practice a little bit more getting these points in class and then drawing the curve. We have one more example down here to do.